Welcome back. In today's class, we will see how to create classes, functions, and modules in Python. We will revisit the vec3 class that you guys implemented as part of the C++ homework. Now we will see how to rewrite this in Python. To create a new class in Python, the syntax is as follows. First, we will write the keyword class followed by the name of the class and then a colon. The name of the class here is vec3. The body of the class begins with the first indented line. The first unindented line marks the end of the body. Now to create a new function, we will first use the keyword def, followed by the name of the function. And then within parentheses, we can pass some arguments to this function. More than one argument will be separated using a comma. And the arguments can either have a default value or not. All the arguments that don't have a default value should appear before the arguments that has a default value. The function declaration ends with the colon again. The body of the function begins with the first indented line, and the body of the function ends at the first unindented line. Now, each class instance can have attributes attached to it to maintain its state, and some member functions or methods to modify its state. Now, let's see how to create some attributes to our vec3 class and how to modify it using some member functions. To create a new attribute, we will use the self keyword. So first, let's see what the self keyword is. Self keyword represents the instance of the class in Python. It's similar to the this pointer in C++, wherein we use the this pointer to access the instance of our class within the class. Now, when we write self.x, we are creating an attribute whose name is x for our vec3 class, and we are initializing it with a value that is the passed parameter. So x on the right hand side is the parameter that is passed to this function. Similarly, self.y equal to y is creating attribute y. Self.z equal to z is creating attribute c for our vec3 class. So our vec3 class now has three attributes x, y, z. And notice this function name is important. The name of the function underscore init underscore begins with two underscores and ends with two underscores. So any method that begins and ends with two underscore is known as a magic method in Python. These methods are not invoked directly by us. They're invoked internally by Python whenever a certain action occurs. So for example, the init method is invoked when a new instance of our class is created. That is, whenever we create a new object of type vec3, this method init is automatically called, and we will construct a new instance of our class vec3. So this function or method acts as a constructor. Now, the member functions, the class methods, have a default implicit first argument, which is self. This is again similar to what we saw in C++, where the member functions had a default implicit first argument. The default implicit first argument was this pointer. Now we will encounter more magic methods throughout this class, which will help us override some of the inbuilt operators. So suppose we want to use the square brackets operator to access a particular parameter of our particular attribute of our vec3 class. We need to override the get item method. So underscore get item underscore is again a class member function. The first argument is the default implicit argument self. It takes one more argument key, which is the index that is passed within the square brackets. Now the body of the function checks whether key is equal to 0. If it's equal to 0, it returns self.x, which is the first parameter, first attribute of our class vec3. If key is equal to 1, we will return self.y, otherwise we will return self.z. So now we can use the square brackets operator with our vec3 objects to access specific attributes. We don't need to use instance.x, instance.y, instance.z to access individual attributes. We can use the square brackets operator instead with an index. Now suppose we want to use the square brackets operator on the left hand side of an assignment statement with our vec3 objects and then assign a value to it. We need to override the set item method. So set item method takes two arguments, key and a value. The key is the index, value is the value that needs to be assigned. So if key is equal to 0, we will assign value to self.x. Otherwise, if key is equal to 1, we will assign value to self.y. Otherwise, we will assign value to self.c. Now next, let's see how to create some static methods. Static methods are methods that don't need an instance of our class to call them. So an example is, suppose I want to create dot product of two vec3 instances, v1 and v2. I don't need to call this function dot using one of the instances. I can simply call dot by passing v1 and v2 as parameters. Now the body of the function is very simple. The body is computing the dot product of these two vectors and return the result back. The method is a static method because we are using the decorator at static method at the top of the function. So in order to make any function declared within the class as static, we need to use the decorator at static method. Also notice the first default argument, which was the self in all the class methods, is missing here. So this is not a class method, it is a static method. And therefore, the first argument is not the implicit default argument self. Similarly, cross is again a static method. It computes the cross product of two vec3 objects. Normalize will simply divide the vec3 that is passed with its norm. So it's converting the vec3v to a unit vector. Now norm is a class method. It's a class method because we need an instance v to be first created to then call norm on. So the default first argument is self, since it's a class method. And the norm function is simply computing the dot product of self with itself and then taking square root to compute the norm. Okay, now next let's see how to use the inbuilt operators like plus, minus, subtraction, multiplication and division to work with our vec3 objects. So suppose I create two vec3 objects a and b, and I want to do a plus b using the plus operator. Then I need to override this inbuilt method underscore underscore add underscore underscore, and once we override this inbuilt method, we can add two vec3 objects using the plus operator. So suppose you create a new class in Python and you want to add two instances of your class, then using the plus operator, then you need to override the underscore underscore add method. Now the body of the add method first checks whether the passed parameter v is of type vec3 or not. If it's of type vec3, we will do element wise addition. That is, we are computing the result which is of type vec3. Each parameter now is self.x plus v.x, self.y plus v.y, self.z plus v.z. We will do element wise addition to create the new to create the result. And suppose if v is not of type vec3, then we will do scalar addition. That is, we will simply add v to each of the three components x, y, and z and create the result. To check whether a variable is of type vec3 or not, we can use the inbuilt method isInstance. This method returns a true when v is of type vec3. It returns a false when v is not of type vec3. Okay, now in order to support reverse addition, that is, if we want to add 0 plus v, we need to override the radd method, which is a reverse addition. So since for addition v plus 0 is the same as 0 plus v, we can simply call self.add within this radd method and return the result of self.add back. Okay, next let's see how to negate a function. So here I'm creating an override for underscore underscore neg. So suppose we have a vec3 instance a and I want to know what is minus a, then we need to override this underscore underscore neg method. This method is simply computing a new vec3, and each of the component of this vec3 is the negative value of the original vec3. So minus self.x minus self.y minus self.z will be the result of vec3. Now To subtract two vec3 instances using the minus operator, we need to override underscore underscore sub. The body is the same, almost the same as what we saw with the add method. So first we will check whether v is of type vec3. If v is of type vec3, we will do element wise subtraction. To do the element wise subtraction, I'm using all the previous methods that we have declared so far. So first we will negate v using the underscore underscore neg method, and then we will use the plus operator to add that result to self. So this should compute self minus v. And if instance is not of type, if v is not of type vec3, then we will simply subtract v from x, y, and z. So self.x minus v, self.y minus v, self.z minus v will be the three components of the result. Now, in order to support reverse subtraction, that is, if we want to do 0 minus v, then we need to override r sub. And since 10 minus v and v minus 10 are different, we can't simply call sub like what we did with addition. We need to support scalar minus a vector as the output of this function. Now the underscore underscore mul is required to override the star operator. So suppose we want to multiply two vec3 objects, we need to override this function. This function again will check whether v is of type vec3. If it's of type vec3, it does element wise multiplication. Otherwise, it does scalar multiplication. Similarly, r mul can simply call mul. Since 10 times v is equal to v times 10, we can simply call mul. And to use the division operator to divide two vec3 objects, we can use true div. So if we override true div, we can divide two vec3 objects using the divided by operator. The body is similar. Is instance v comma vec3 will check whether v is of type vec3. If v is of type vec3, we will do element wise division. Otherwise, we will return division by a scalar. Now, the next two methods are underscore underscore eq underscore underscore ne. So suppose we want to use the equal to operator to check whether two instances of vec3 class are the same or not. We need to override the underscore underscore eq method. And to check whether two instances are not the same using the not equal to operator, we need to override the underscore underscore ne method. The body is very simple. First, we will check whether self.x is equal to v.x and self.y is equal to v.y and self.z is equal to v.z. If all three are equal, then we will return a true. If even one of them is not equal, we will return a false. The negative of that logic is used for not equal to. So if self.x is not equal to v.x or self.y is not equal to v.y or self.z is not equal to v.z, we will return a true. So even if one of the three components don't match, we return a true. Only if all three components match, this function will return a false. Now the last method here is underscore underscore str underscore underscore. This method is used to convert the instance of our class to a string. So this method will be useful when we want to pass our vec3 objects to the print function and print it as a string. The body of the function works as follows. First, we will check whether the components are of type float or not. If it's of type float, we will format the resulting string using floats as the format specifiers. If the individual attributes are of type integer, we will format the string using the integer format specifiers. So here I'm computing a new string. I'm using the dot format method with the braces to fill in these placeholders. The (f) here simply says that the passed parameter will be a floating point number. And else here (d) will simply say that the passed parameter is an integer. So this completes the vec3 class.